Dear students, in our last lecture we have studied how to find out the inverse of a matrix by row transformation and as well as column transformations. In that lecture we have taken one matrix which is of order 2 by 2. Today also we will discuss about how to find out the inverse of a matrix, and we will take one example of matrix whose order is 3 by 3. So let us see. The question is find the inverse of following matrix by elementary transformations. So you can prefer either row transformations or column transformations. We will discuss both the methods by taking just one example. So let us take one matrix of order 3 by 3. See, this matrix is given to you. Now we will first of all we will check that whether this matrix is invertible or not. So for that we will calculate its determinant like this. So see how to find out the determinant of 3 by 3 matrix. So first of all select first element 1 into, how will you find out determinant? See, remove this row and column and remaining element as a determinant. So 2 into 1 is 2 minus 3 into 2 is 6. So 2 minus 6. Then take this second element and take minus sign. So minus 0 into, again remove row and column, corresponding row and column of that 0, and then 0 into 1, that is 0, and minus 3 into 1 is 3, means 0 minus 3. Then plus, take this element, that is 1, again remove row and column, and then 0 into 2, that is 0, minus 2 into 1 is minus 2, like this. So this is the procedure to get the determinant. Okay, so see the calculation, that is equal to 1 into, this is minus 4, then minus 0 into, this is minus 3, plus 1 into, this is minus 2. And then by solving we get it is equal to minus 6, which is not equal to 0. So if the determinant of the matrix is not equal to 0, then matrix is called as non-singular matrix. You know that very well. And if the matrix is non-singular, then that matrix is invertible. So now we will find out the inverse of this matrix. Okay, so if you want to use the row transformations, then we have to choose this equation, A into A inverse is equal to I. So just write the equation in the matrix form like this. A inverse as it is, this is matrix A is given, and on the right hand side this is identity matrix of order 3. Now by our procedure we have to transform this matrix into identity matrix, this matrix, given matrix, to identity matrix. So for that we require 1 here, then we require 0, then here we require 0, then next step will be for to get 1 here, then 0 here, and then 0, and then we require 1 here, then 0 and 0. So this is the method that we have to use while performing row transformations. So here already 1 is there, so we get 1 here, already it is given, then here it is 0, now we require 0 here, so we will use the proper transformation to convert this into 0. Okay, so how will you find out this? So we have to change row number 3, see, like this, R3 we have to change as R3 minus R1, means if you subtract row number 1 from row number 3, then you will get 0 here. So just think about this element, don't think about other elements. Okay, how to get 0, that is our main part here. Okay, so just if you do the rough work, then see how will you change row number 3. Just subtract it, row number 1 and row number 2 as it is, and see here 1 minus 1 we get 0, then 2 minus 0, that is 2, and here also 1 minus 1 is 0. A inverse as it is equal to, we have to follow this procedure on the right hand side also. So 0 minus 1, that is minus 1, then 0 minus 0 is 0, and then 1 minus 0 is 1, like this. Okay, so you have to write the row number 3 like this by this transformation. So here we get 0. Now we required 1 here. Our next procedure to get 1 here in place of 2. Now if that means we have to change row number 2. Now either you can use row number 1 or row number 3. By the use of row number 1 or row number 3, you have to find out 1 here. But it is not possible if you observe here. Means if you add or subtract or by multiplying the first row or third row, and if you add or subtract, it is not possible because there is 2 here. Here also it is 2. So if you think about that, then if you want to change row number 2, then this transformation is proper transformation. Just you divide the second row by 2, then you will get 1 here. Okay, otherwise we can use row number 1 or row number 3 also, just like here we use row number 1 to get 0 here, but it is not possible in this case. So that's why you can divide row number 2 by 2. Okay, so that we get 1 there. So see how will you get. So these are fixed elements now, 1 0 0. Don't change these elements. So take care that the previous elements that you have changed, that further you don't change that. So 1 0 0 remains as it is. So here after dividing by 2 we get 1, and here it is 3 by 2. Just focus on row number 2. Here also if you divide, then you will get this row. Okay, so here we get 1. Now we require 0 here, and it is already there, so no problem. Then we require 0 here. Okay, so after getting 1 here, we require 0 here and here, but here it is already given to you, so we require 0 here. So row number 3 that we have to change. Now to get 0 here, we have to use row number 2, not row number 1, because if you use row number 1, then this will change. Okay, just think about this. So strictly we have to use row number 2, means if you subtract row number 2 by multiplying by 2, means 2 minus 2, you will get 0 here. Okay, so see here the procedure. So R3 changes to R3 minus 2 times R2. This is the proper transformation to convert this element to 0. So just you think about this. So focus on row number 3 now. Row number 1, row number 2 remain as it is. Just you use row number 2 to change row number 3. So here it remains as it is. This 0 remains as it is. Okay, then here it becomes 2 minus 2, so 0. Now this is 0, and 0 minus 2 times R2. 0 minus 2 times R2. So minus 2 into 3 by 2, that is minus 3. So here you will get minus 3. Okay. See here properly, row number 3, R3 minus 2 R2. So here on the right hand side also, first row, second row as it is. Now think about third row, minus 1 minus 2 times 0. So it remains as minus 1. Then 0 minus 2 times 1 by 2, that is minus 1. And 1 minus 2 times 0, so that is 1 here. Okay, so here you will get third row like this. Okay, now after this procedure, now we required 1 here. In place of -3, we required 1. So it is convenient to divide this row number 3 by -3 so that you will get 1 here. So divide the third row by -3. So hence we get this. That's why we get 1 here. So no change in 0 because 0 divided by -3 is 0. So here it is 0. Here you will get 1. Same procedure if you apply here. Just focus on row number 3. First row and second row as it is. So it becomes, here it is 1 by 3, then 1 by 3, and here it is -1 by 3. We have to divide by -3, remember. So -1 upon -3 is +1 by 3. Here also it is +1 by 3, and it is here it is -1 by 3. Okay, so we completed up to this. Here we get 1. Now we require 0 here and then 0 here. Okay, so what will you do? Just see here. R2 changes to R2 minus 3 by 2 R3. If you see that previous step, see the previous step here. What is the procedure? We have to change R2. How will you change R2? Means to get 0 here, R2 minus 3 by 2 times R3. R2 minus 3 by 2 times means 3 by 2 minus 3 by 2, you will get 0 here. That's why we use that. So see the next step, that by this transformation, here you will get 0. Other elements as it is. So A inverse, and if you apply here, second row becomes, here it is, you will get -1 by 2, then 0, and then 1 by 2. And third row as it is. First row is also as it is. You have to change the second row only by this procedure. Okay, so see the previous step and check this whether this is correct or not. Okay, so we get 0 here. Now last step, that we required 1, we required 0 in place of 1 here, so that it becomes an identity matrix. Okay, so we have to change row number 1 as R1 changes to R1 minus R3, means 1 minus 1, you will get 0. So we get identity matrix here. Same procedure apply to first row of this matrix. Then see, 1 minus 1 by 3 is 2 by 3, 0 minus 1 by 3 is -1 by 3, and 0 minus minus plus, so 1 by 3. So first row on the right hand side is like this, second row as it is, and third row also as it is. So hence we get identity matrix here. So I into A inverse is equal to, we get new matrix on the right hand side, and I into A inverse is A inverse, so A inverse is equal to B. So that's why we can say that A inverse is equal to, this is a matrix which is called as inverse of the given matrix. Okay, this is by row transformations. So the proper use of row transformation to convert the given matrix into identity matrix, and if you apply the same procedure on the right hand side, then you will get the new matrix which is called as inverse of a given matrix. Okay, so this is one example to get the inverse of a matrix by row transformations. Now we will solve same example by using column transformations. Okay, so take the same example. Again the question is same, find the inverse of the following matrix by elementary transformations. In exam it's your choice whether you have to use row transformations or column transformations, but now we will solve this same matrix by using column transformations. So first of all we have to check the determinant, its determinant. So same calculation, see this, it is -6, so the matrix is invertible. Okay, so first of all we check that whether it is invertible or not. Now if you want to use column transformations, then we have to use this equation, because this is a post factor. A inverse into A is equal to I, and if you want to convert the matrix A to identity matrix, then you have to use this equation. A inverse A is equal to I. So write down the equation in the matrix form. Now what is the procedure by column transformation? First of all, we required 1 here, then 0 here, and then 0. Then 1 here, then 0 here and here. Means row wise we have to convert. We have to follow this order strictly. While performing row transformation, we have to convert 1, then 0 column wise. In case of column transformation, we have to convert the elements row wise. So here we required 1, then 0 here, and then 0. Then we required 1, then 0, then this 0, and then here 1, and then other two as 0. So if you think here, or if you observe here, then there is 1 already. Here it is 0. Okay. Now we have to do the procedure to get 0 here. So we have to change column number 3. Now think about column. So column number 3 to get 0 here. How will you get 0? If you see C3 changes to C3 minus C1, means if you subtract column number 1 from column number 3, just think about this element only. So 1 minus 1 becomes 0. So what will you get? Now write the first column as it is, second column as it is. Now just you subtract column number 1 from column number 3. So 1 minus 1 is 0. Then 3 minus 0, that is 3. 1 minus 1, that is 0. So column number 3 changes like this. Now here in this case also, write the first column as it is, second column as it is, and here 0 minus 1, that is minus 1, 0 minus 0, that is 0, then 1 minus 0, that is 1. So just you change the column number 3 like this on both sides. So we get 0 here. Now what is the next step? Here we required 1. In place of 2, we required 1. So we have to change the column number 2. Now we have to use the column number 3 or column number 1. Otherwise you can divide also. Divide by 2. By dividing 2 also you will get 1 here. So now this 1, 0, 0 are fixed. So don't change that. Okay. So keep in mind that 1, 0, 0 are fixed. We have to follow the column transformation to get 1 here. So what will be the transformation? See, here we use that it is possible to use as C2 changes to C2 minus C3. See, C2 minus C3. This is also one transformation to get 1 here. Or you can divide by 2 also, means another transformation is also there. If you divide C2 by 2, then you will get directly 1 here. But by this transformation, what will you get? See here. Write first column as it is. Now C2 minus C3. 0 minus 0, that is 0. Then 2 minus 3 is minus 1. And 2 minus 0 is 2. Like this. Okay. Then here in this case, column number 1 as it is. We have to change column number 2. So 0 minus minus plus 1. So here we get plus 1. Then 1 minus 0, that is 1. And 0 minus 1, that is minus 1. So subtract the row number, subtract column number 3 from column number 2. We get this column number 2. And column number 3 as it is. Now why we do this transformation, that is C2 minus C3? Here we required 1, but here we get minus 1. So further transformation to convert that minus 1 into 1 as C2 changes to minus C2, means just you multiply second column by -1, you will get 1 here. Okay, otherwise you have to divide by 2 here, so that directly you will get 1. Or if you use this transformation, then next transformation will be C2 changes to -C2. Okay, so hence we get this. Just you divide, you multiply by -1, so we get 1 here. Now the next step is, we required 0 here, but it is already there. Then we required 0 here. By getting 1 here, next procedure is, we required 0 and then we required 0 here. But here it is already there. So how will you get 0 in place of 3 here? So we have to do the 3 minus 3. Okay. So for that, we transform like this. We have to change the column number 3 as column number 3 minus 3 times C2 minus 3 times C2. 3 minus 3 you will get 0. Okay. Other elements remains as it is, means other changes that you have made in this transformation are as it is. Okay. So what will you get? See here, first column as it is, second column as it is, third column changes as, see, 0 minus 3 times 0, that is 0. Then 3 minus 3 times 1. So 3 minus 3 times 1 is 3. So 3 minus 3 is 0. Then 0 minus 3 times 2. 3 times minus 2. So minus 3 into minus 6 is plus 6. Okay, on the right hand side, first column as it is, second column as it is, and in third column what will you get? Now see here, minus 1 minus 3 into this. So minus 1 plus 3, that is 2. Then 0 minus 3 into minus 1. So 0 plus 3, that is 3. And 1 minus 3 into 1, that is 1 minus 3, that is minus 2. So do the rough work here if you want, and just you perform this transformation. So C3 minus 3 times C2. Okay, so here we get 0, that's why, by this transformation. Now next procedure is, here we required 1. In place of 6 we required 1. So the very easy transformation that we required, that just you divide the column number 3 by 6 and we get the here 1. Okay, so also you divide here also. On the right hand side, if you divide, then you will get this column. Column number 1, column number 2 remains as it is. Okay, so we get 1 here. Now we require 0 here as well as 0 here. If you think about this, then see here, if you want 0 here, then C2 plus 2C3 is the proper transformation. We have to change the column number 2. So minus 2 is there. So minus 2 and plus 2 becomes 0. So that's why C2 plus 2C3 gets 0 here. So we have to change the column number 2. So column number 1 as it is. And then column number 2, see, 0 minus 0, 0 plus 2 times C3 is 0. Then 1 as it is, and minus 2 plus 2 times C3, so that's why we get 0 here. And third column as it is. Now same procedure you apply on the right hand side. First column as it is. Now second column, that is here, minus 1 is there, minus 1 plus 2 times C3, so minus 1 plus 2 into 1 by 3. So minus 1 plus 2 by 3. So minus 1 plus 2 by 3 is minus 1 by 3. Then minus 1 plus 2 times 1 by 2. 2 times 1 by 2 means 1. So minus 1 plus 1 is 0. Then 1 plus 2 times minus 1 by 3 means 1 minus 2 by 3. 1 minus 2 by 3 is plus 1 by 3. So do the rough work and check that all these elements. third column remains as it is. Okay. Now last procedure, here we required 0, so we have to change the column number 1. So there is a transformation like this, C1 changes to C1 minus C3, C1 minus C3, 1 minus 1, you will get 0 here. So see this, here you change the column number 1, so 1 minus 1 by 3, that is 2 by 3, C1 minus C3, 1 minus 1 by 3, that is 2 by 3, then 0 minus 1 by 2, that is minus 1 by 2, and 0 minus minus 1 by 3, that is plus 1 by 3, and other two columns as it is. So here we get identity matrix. So hence you can write it as A inverse into I is equal to, this is a new matrix B, and hence A inverse is equal to B. So we get the inverse, that is the inverse of the given matrix. So we calculate or we find out the inverse of the given matrix by row transformations as well as column transformations. So given matrix is of order 3 by 3. In last lecture we have completed 2 by 2 matrix by row as well as column transformations. I have discussed just one example of it. You try it as a you can solve many examples like this. If the matrix is invertible, then in case of 2 by 2 matrix or 3 by 3 matrix, you can choose row transformations or column transformations like this. Okay, so I hope you have understood all these methods, means row transformations as well as column transformations. Okay, thank you.